Why, hello there. Hey, what's up guys, my name is Cherno. Welcome back to another Hazel Devlog. It's been so long since the last one, and a lot of you probably think that I have just either abandoned Hazel or I've just gone on some holiday and I've just forgotten about all of you, but the truth is I've actually just been working really hard, and sometimes when I am working on a difficult project, I kind of tend to forget to make videos, or I don't feel like making videos, and instead I tend to focus on the programming and focus on the actual work. Now, that's not really like, every time I look back at this, I don't really like this, and I think that it would probably be a lot better for me, instead of like going down this huge rabbit hole of just, you know, depression, basically trying to fix certain problems. Instead of all of that, it's probably just better to just sit down and fill you guys in with what's actually happening. And this is basically what this video is. So I'm gonna be showing some stuff that isn't really completed in Hazel Dev yet. And it's very much work in progress. I'm just gonna kind of talk to you about what it is that I have been working on, and you know, various problems that I've kind of encountered on the way. So first of all, what have we been working on in Hazel Dev for like the last couple months? So first of all, you know, when I say Hazel Dev, I'm referring to like the Patreon version of Hazel, like my version of Hazel. The Game Engine series is something else, and the Hazel that we're building in the Game Engine series is kind of like a, you know, it's going to be leading up, it's going to be getting into the stuff that's in Hazel Dev later on, but Hazel Dev is kind of like my version of the engine that I'm working on, along with a few like amazing contributors as well who are helping me out. So that's what Hazel Dev is. So I'm not really talking about the Game Engine series. Game Engine series is going great. I'm working on like a material system for that, and like figuring out all the shader stuff. I've been live streaming on Twitch TV/the Cherno a lot, working on both the Game Engine series and Hazel Dev. But specifically Hazel Dev, the thing that we're working on at the moment is basically supporting two rendering APIs, OpenGL and Vulkan. So OpenGL is still something that I want to support, because certain devices don't, like older devices may not support Vulkan, but also because I think that OpenGL is a really nice kind of API for anyone learning graphics programming. It's still something that I recommend as the kind of the graphics API you should start with if you're just learning about graphics programming, because instead of spending all of your time, you know, trying to figure out all the code you need to, for example, generate mip maps in Vulkan, you can just write GL gen mip maps or GL gen texture mip maps in OpenGL and you're done. It's one line, right? So my point being that instead of focusing on the actual API, you focus a lot more on the theory of actual graphics programming. You write shaders, you write, you know, the code that you need, like the actual graphics programming itself, and not the API, is where you spend most of your time in OpenGL. You decide how to render things, what techniques to use, what shaders to use, that kind of stuff. Whereas Vulkan's more like low level and more about like the driver and, you know, memory access and memory control synchronization, that kind of stuff. So I still really like OpenGL, and I still think it's a great API to have, especially in a series that is very much kind of, you know, it's supposed to be for educational purposes, and then Hazel Dev being an engine that kind of takes that way further. So I am keeping OpenGL for the time being. So anyway, but adding Vulkan, first of all, Vulkan, right? Lots of people always talk about how hard Vulkan is, and the thing is, yeah, it's a lot more verbose. It's a much lower level API. It's supposed to be more kind of, you know, about the controlling exactly what the driver is doing, rather than running, you know, one line of code and then having the driver figure stuff out on its own that you don't even have any awareness about. So it is supposed to be like that. I haven't found that part too difficult, to be honest. I have been exposed to Vulkan for probably like since like, I don't know, 5 years ago or so. I remember back when I worked at EA, before Vulkan was even out, you know, NVIDIA would like send us drivers, and we would basically test, you know, that on like, you know, we would kind of integrate Vulkan into our engine and then run that on like Android devices, and then watch them reboot when the driver crashed and all that fun times. But I guess I'm kind of used to Vulkan, and I don't think that part is too difficult, especially because the validation in Vulkan is a lot better than OpenGL. Still not as good as like DirectX. It's not as mature as DirectX either. So that's kind of to be expected, but the tools and the debugging, kind of the validation, is definitely a step up. So in general, Vulkan has actually been a decent experience for me. I don't think that it's been too difficult, but there are still a lot of kind of difficult problems to solve when it comes to, first of all, making a kind of API independent renderer and an API independent rendering API. Because one of my goals with Hazel is not just to kind of have, you know, oh, here's a version of Hazel that uses OpenGL, here's a version of Hazel that uses Vulkan. No, what I want is I want to be able to actually create a kind of API independent renderer API. Lots of API wording here, but basically what I want to do is create like a render API that is completely abstracted away from the backend that it's using, whether that be Vulkan or OpenGL or DirectX maybe in the future, that kind of stuff, right? So instead of actually kind of being very tightly coupled to the render API, you should still be able to, like, in an abstract way, basically set up like all of your, I don't know, textures, buffers, you know, shaders, pipelines, render passes, that kind of stuff. And then, you know, behind the scenes, that will translate into OpenGL calls if you're running Hazel with OpenGL, or Vulkan calls if you're running it with Vulkan. So that way you can actually, you know, write your own renderer instead of having to even use Hazel. So, and you can do that in a very, very kind of cross, you know, API independent way, we'll say. So because of that as well, you know, everything has to be kind of, this API has to be designed in a way that works with everything. That can be difficult at times. But then the other thing is, you know, for example, like the shaders we write in Vulkan GLSL, and then that gets compiled, that gets cross-compiled into like OpenGL compliant GLSL, and then we use that with SPIR-V as binary shaders for OpenGL and for Vulkan. So like the shaders are the same, which is good as well. And then if we use DirectX in the future, they'll probably also be written in a single language, and then cross-compiled into everything else. So the general way that, like, everything seems to work and everything seems to be not too bad, but there are still kind of edge cases and certain situations where I do wish that like Vulkan would be better at validation and at kind of debuggability, we'll say, because sometimes the driver will crash and it won't tell you why, and you'll have nothing to go on, and that's kind of where I'm at right now. And it happens different. It happens on different drivers. It happens at different times. It can happen, you know, on my desktop, for example, with a 1080 Ti. I've seen it happen like once in the last month, but then like on my laptop with like an RTX 2060, you know, it happens 1 in every 10 runs. So if I just keep running Hazel, the driver will crash at some point, which in Vulkan is kind of like a device loss kind of error. And then OpenGL sometimes will crash as well randomly. And then for some people, it's like they run it and it's like 100% chance of it crashing. So there's certain things that are very difficult to kind of debug, and I do wish that Vulkan would be better in that sense. But the other thing that I wanted to say is that the way that I've designed this as well is that the API kind of switching, the API, like which API you decide to use when you actually run Hazel, that's a runtime kind of decision as well. So you don't need to compile Hazel with OpenGL or compile Hazel with Vulkan. It's actually like right before you basically create the context and right before you create the window, you can specify if you want Vulkan or OpenGL just in the C++ code. So it can be a completely programmatic decision. And that's kind of cool because it means that, you know, you could restart in a different API, or you could change APIs, I guess, theoretically, while you're running. You might have to like recreate the window or recreate the context, but you can keep everything else in memory. You don't need to just completely rerun the whole application. And you can also on startup read like some configuration file or generate a random number, and if it's even, then Vulkan will be used. I mean, you could really do anything, which is kind of cool, I think. But anyway, let me show you where I'm at. This is, again, as I mentioned, it's gonna be a pretty chill video. So let's just run Hazel and I'll kind of give you guys a bit of a tour. So the crash happens a lot of the time when environment maps are being used. So the way that we create environment maps is basically we read in like an HDR equirectangular map. And then we, there's so many videos I've been wanting to make on Hazel about all this kind of architecture stuff. Let me know what you guys are interested in. Because there's a lot of render API kind of design and architecture that I could talk about, as well as like this environment map stuff. If there's something that I ever mentioned that you guys want more information about, just drop a comment, and maybe I'll see that comment, and maybe I'll be like, I'll be super inspired to like make a video and be like, okay, that's it, I'm making a video on that. But environment maps are rectangular, they get converted into cube maps, they then get filtered using a really nice kind of filtering algorithm so that like the lower MIPs basically aren't just generated by, linearly interpolating, but they're actually kind of sampled in like a very nice kind of blurry fashion that just makes it buttery smooth when you actually downsample them. And then also we generate an irradiance texture as well. So we have 3 compute shaders that run to create all of those maps. And so we wind up with 2 texture cubes, so 2 cube maps, which have been properly filtered as well for all of their maps. And that's how we use environment maps. But unfortunately, it's a little crashy. And that's kind of what I'm talking about. And so what will happen with Vulkan is Vulkan will give me like a, what is it like? Yeah, a VK error device lost, which basically means the driver has crashed and no other validation. So first of all, if there are any like developers watching this who have had experience with this, if you have any advice for debugging this, please let me know. I have actually been using the whole like NVIDIA checkpoint stuff. So NVIDIA actually have a little extension that you can use for these kind of diagnostic checkpoints that you can litter about in your code. And I've tried using them and then retrieving them later and seeing, but I don't know, it just kind of, it's supposed to kind of give you an idea of where the crash is happening, but it doesn't really give you much more than that. So I have tried that, it hasn't been that helpful in my experience. Maybe I just haven't tried hard enough. But basically, the way that I got around this crash, which is interesting, because this is a bit of a creative solution. It's not really a solution, I haven't solved it yet. But the problem is that there's a lot more in this engine than just graphics and rendering. And, for example, we have a new person kind of working on the Hazel team now who's going to be doing the audio stuff for Hazel. So like, all of the audio programming basically, so that we can have, 3D audio and, well, anything to do with audio, basically all the tools we need as well. And that obviously has nothing to do with environment maps. And if Hazel is so unstable that it just crashes randomly, that person might be like, okay, whatever, I don't care that your cube maps don't work. I need the engine not to crash. And so a lot of the time when you're working in a team, it's important to obviously consider the fact that just because one thing might not work doesn't mean the whole system doesn't work. And so what I did was on startup, I made this little this kind of little modal dialog here that basically just says that environment maps are currently disabled by default because they're a little unstable on certain GPU drivers, and then there's an option to enable them. So we can enable them because it probably won't crash. And so if we were to, for example, like create a skylight and then go into like the environment panel down here and just grab like this one. I'm running a debug build, so this will actually take a little bit of time to load it because it does have to run all those compute shaders. See, this will work, right? And so we have our environment map, and obviously if we like create like, I've actually got this objects panel now. If we create like a sphere and a plane, or whatever, let's maybe select the plane, make it a bit bigger. Then of course you can see that we are actually using that environment map. There's this weird little bright spot, by the way, in the middle that I just noticed, which is a bit, I think that's been there for a while, actually. Probably some shader bug. Anyway, oh yeah, and also, we can add a directional light. You can see shadows are working. So this is actually running Vulkan, by the way. I didn't really point that out, but this is running in Vulkan at the moment. And I can actually go to File and then restart with OpenGL. This is something I just added. And then it will actually relaunch it in OpenGL. And you should see, again, debug builds, it's a little slow. If I enable this as well, we're now running in OpenGL. And of course it looks the same. I think I've got VSync enabled, so the frame time might be kind of different. But, if I add that skylight back and recreate that scene, you should see that it kind of should work the same way. So we can kind of run them, of course, in both APIs. And that's basically the big change here. That's kind of, if this is a devlog, right? So since the last episode, which I think was about, was it really about 3D physics? Is that the last thing I showed? Or like the first person camera controller, I think. So since then, this is kind of what I've been working on. And then Peter, for example, Peter has been working on other people in the Hazel team, which I need to, I really need to make like a little contributors thing so that we can actually list everyone who's contributed. But Peter has been working on like this asset system basically with all this asset panels. So that's kind of his doing. And then we've got some other really exciting stuff in the works that I will reveal as it gets kind of integrated. But you know, there's been other stuff going on. It's just that I've had my head in this Vulkan issue, and I've kind of been neglecting to make devlogs, which is not good. So I accept that that's not good. Anyway, we can leave them off, and if we leave them off, if we load a scene that has them, pretty much everything has them, to be honest. I can load this shadow test scene. This does have a skylight, but then also, like, you know, today, for example, day in the life of Cherno, I spent about 15 minutes being like, okay, well, today's going to be the day that I solve this. And then I got bored. And so I'm like, wouldn't it be nice if we didn't even use cube maps? Why don't we have some kind of dynamic sky model? And so I added that. And so we actually have this option for dynamic sky here, which I can enable. And then if I kind of change some of these parameters, then you can see that we actually have a sky that's been created. This is like the Pritham sky model. It's pretty popular. And you know, we can basically change the time of day. And well, that's a little bright there. Let's kind of change some of these settings. So we can change, and this has nothing to do with directional light, so the shadow and stuff will be completely not related to like the sun position. But yeah, we can like change this, you know, change the time of day, change the kind of position here or whatever. This is kind of like the brightness. And yeah, we have this like essentially the sun that moves around, and the time of day is linked to the kind of, well, the light kind of style is linked to the inclination of the sun and like the position and what the time of day is and all of that, which is pretty cool. So that's like, you know, that's kind of what a lot of the times what I end up doing. I end up being just getting distracted and being like, oh, look, a shiny thing, I'll just add that into the engine, which is kind of like, you know, it's a bit annoying in a way, because maybe I should be solving this problem, but on the other hand, I feel like it's important to you know, somewhat kind of, I guess, you know, reward yourself almost at times with like, you know, giving yourself a bit of a break and letting yourself do something creative, because solving a driver crash is not really that creative. I won't say it's completely not creative. I mean, there have been some creative things I've tried, but it's not as creative as, you know, doing something like this sky. So I think my point with this is that even though I haven't solved this driver problem just yet, I think it's really important to take a break and to take a deep breath, and also to be aware of the fact that sometimes, even when it seems like whatever you're working on is never going to have a solution, it probably is. And if you look back at your own life and you look at situations in which, you know, you've also thought that everything's hopeless and this is never going to work, I'm never going to work this out, you probably have. You know, like I'm sure I had a bug 5 years ago that I was like, no, I'm never going to be smart enough to fix this. I have no idea why this is happening. This is the worst. I should have just used Unreal Engine, you know, whatever it might be. And then if you look back at that and then realize that, oh, actually, that wasn't too bad. I solved that like a few weeks later, and sure, it was hard, but I did it. Then that will maybe inspire you to not give up and to finish this, even though I am this close to just completely giving up. But anyway, so yeah, so we have this cool sky. Don't even need cube maps anymore. So life is great. No, I'm kidding. I do have to solve that bug though, seriously. But anyway, let me know what you guys thought of this little video. I know this wasn't really like anything that kind of dramatic. But yeah, we now support Vulkan, which is pretty exciting. If you want more information about the shader pipeline, more information about the sky that I added today, which was like about an hour, so it's probably really raw and needs some love, or like really anything else that's new, then let me know in the comment section below, because these devlogs, like, you know, I will make them on any topic I feel like, but I also want to kind of talk about things that you guys might be interested in. And I know that I haven't even covered things like shadows yet that I said I would do in much more, in a much kind of more in-depth video, I guess. So if there's something that you want to see, please let me know. Otherwise, thank you guys for watching. Hope you enjoyed the video. Please don't forget to hit the like button. Also, don't forget that you can go to patreon.com/thecherno to help support the development of Hazel and the Game Engine series and everything that I'm doing on my YouTube channel. You'll also get access to this. Like what you just saw here, this is all committed and pushed and on GitLab and ready for you to you know, inspect and maybe even fix the bug for me. Like, the thing is, seeing the engine at this stage where it's already like, you know, it's looking pretty cool. You know, we've got like, it almost looks like an engine now, and it's almost ready for me to actually start creating stuff with it. Cause that's something that I honestly am so excited about. Like, I'm excited about, you know, getting all of this kind of, you know, I don't even know what to call it. All of this kind of, you know, first, you know, minimal viable product, you know, vertical slice kind of stuff done, so that we have all of the basic features of what we need in a game engine done, so that we can actually start creating content on that, creating games, creating, you know, scenes, building stuff, you know, all of that kind of stuff. And that's really where all of this is heading. As well as obviously, you know, the educational side of it with the game engine series, but then also the content creation side of it, which I'm going to start doing a lot more videos about when Hazel reaches that point, which hopefully will be maybe by the end of this year or something like that. We'll see. But yeah, making a game engine is definitely a lot of work. But thank you guys for watching, and thank you for all your lovely support. I don't think definitely would not be anywhere near this level if it wasn't for you guys. Because your support is really what keeps this project happening. So thank you so much for all of that. I love you all, and I'll see you next time. Goodbye. Yeah, we're not going to talk about the hair.